Hello friends, it's 3 a.m. here in Gainesville and I'm doing my first YouTube video and I'm pretty excited about it. I would like to take this opportunity to thank Professor Oliver Wu for this experience. I'm Prithvi, a graduate student at University of Florida and I am presenting my final project as part of the course Pattern Recognition. The topic for the project was image classification using deep learning, specifically convolutional neural networks. For this purpose, I have selected the Yelp dataset, which was provided as part of the Kaggle competition. Let's take a look at the problem statement. So each day, there are thousands of photos which are uploaded on Yelp by its users. Can we extract meaning from this data to further the business? In one word, yes. Yelp hopes to automate this task by extracting meaning from these photos by building a classification model which would classify these images into a set of labels. Let's take a look at the labels. So these are the labels. So as a vision engineer, how would I go about designing features to extract these particular labels? So it's a pretty hectic task and we would like this to be done automatically, and that's where deep learning comes in. So I'm going to talk about the approach I've taken. So consider we have a 28 into 28 image, that is the resolution is 28 cross 28. So which means we need 784 pixels to represent the data in the image. So when we represent, if we consider a normal neural network, we input this image as a 784 dimensional vector, and we are treating each pixel the same. The pixels that are very far apart, we are treating them equal. So we are not considering the spatial structure of an image. So that is the reason why we choose CNN, convolutional neural network. It's a special kind of neural network which helps in classifying images better. So the approach I've taken is there are three stages to this project. The first stage is I feed in the dataset to a model called as CafeNet to extract the features, and then I take a mean to extract the business features. And once I've done extracting the business features, I pass them through support vector machine to get the predictions. Stage 1. In stage 1, I do the extraction part, the extraction from the images. So what is CafeNet? CafeNet is a pre-trained model which was trained on ImageNet, which is a database of images worth 110 GB. So once you train the model using ImageNet, you get a set of weights and biases. So this is our starting point for the project. So now we are going to pass the training data through this model to fine tune these weights and biases so that it classifies our images better. So once this process is done, a H5 file is generated, which is a dictionary of image IDs and its corresponding feature vectors. Now let's take a look at how an H5 file looks like. So this is the way it looks like. It's approximately 4 GB of size, and you could see it has a photo ID and feature corresponding to each photo ID. So next comes the business stage 2, which is calculating the business features. So the output from stage 1 becomes the input to the stage 2. This is the way a neural network works. So the HT file gives mapping between the image IDs and its features. Now there's another data set which was provided by Yelp called as train photo to biz IDs, which has a mapping between business IDs and image IDs. So in effect, through transferability property, we get a relationship between business ID and features. And then a mean feature vector is calculated for each business type. Now here, our business, for example, take McDonald's. There are so many branches to McDonald's across the world, and There's so many people who upload images from all across the world, so each business has multiple instances. So it comes under multiple instance case inputs. So then comes the process of mean calculation. So you obtain feature vector for each image corresponding to one business. So there are millions of images corresponding to one business, and then you compute the mean of all the feature vectors. In a way, you are taking the proper representation of the business. So this is how a sample data set looks like after the processing, after calculating the mean vector. So this is the mean vector, and this is the business ID of the restaurant. So 1000, you can say, is represented by McDonald's, and these are the labels associated with it. The sample test data, the test data doesn't have labels because that's what we're going to do. We're going to predict that. So in a stage 3 comes the prediction, the main part. Here we are going to use SVM. So the output from stage 2 becomes the input here again. So this becomes the input, and this becomes the input when you are trying to predict the test data. So as I've told you, each business consists of multiple instances already, and there are multiple labels to be predicted. So this becomes a case of a multi-instance, multi-label SVM. So we are going to use a linear SVM here. I've used a Python library, scikit-learn linear kernel implementation here. Internally, there are 9 different SVM implementations for each of the labels. Each attribute has its own one versus all implementation. Suppose the support vector machine has a threshold of 0.5 and the input is evaluated at every SVM, and the output is 1 if the value is greater than 0.5 and 0 otherwise. So the output at the end of all the process would be a 9-dimensional vector. So if you say that the restaurant is good for dinner, takes reservations as alcohol, ambience is classy, it would be perfect to take someone on a date, and its output would be 0 1 1 0 1 1 0 0 1 0. Next, we have to do the performance evaluation of our model. So we consider two different. We do not consider accuracy in this case, but we do consider two other parameters, standard parameters called as precision and recall. Precision is defined as a ratio of true positives to all the predictive positives. So it indicates how well the model is performing. Recall is a ratio of true positives to all true positives. It indicates how many are correctly classified. Low recall means that we need to fine tune our model or maybe redesign our model from scratch again. So FN score represents both. It's like a weighted average of precision and recall, and it's mathematically the harmonic mean of precision and recall, and it's defined by this formula. So our model produces an FN score of 0.76. So the higher the FN score, the better it is. So in this project, I have not only tried to classify our input images, but tried to implement search mechanism on it. So I tried to use the ELK stack. ELK stands for Elasticsearch, Logstack, and Kibana, and this offers real-time search and data analytic capabilities. So the raw data in the form of images is fed into our model, and the labels are predicted, and then these predicted labels are taken by Logstack and routed to Elasticsearch, where the data is indexed. And once the data is indexed, we use Kibana to create powerful visualizations and query on real-time predicted data. So you can see the visualizations in the next slide. created using Kibana. So you can see the label corresponding to 6 has 9074 images in it. And this is a bar chart corresponding to it. More visualizations. Here this is a pie chart and a line chart. It was a wonderful experience working on this project, and I hope you enjoyed this presentation. Thank you.